As I told you that I will be talking about these multiplexers, demultiplexers, encoders and decoders. Let us see how much I can do today. I have already completed this in the theory class. Let me just see this. So we have multiplexers. Let me just give you a brief introduction, then I will show you the simulation. So now you have multiplexers. 2 is 2 to 1. Multiplexer is many to 1. So it can be 4 to 1, 8 to 1 or 16 to 1. So what this number here indicates, the number of inputs, the number here is always 1. So many to 1. So and if there are n data inputs, the number that you can get is 2 to the power m, which is equal to n. And this is a block diagram of the multiplexer. I am using the circuit board simulator prepared by IIT Bangalore. We are thankful for their that is being developed. It's immensely useful for all our students. So let me take this disclaimer, and these are the data inputs, and this is your enable. Once the chip is enabled, then it is ready for transfer of the data from the input to the output. So these are the select lines. These select lines will select, since there are many inputs, only one input will go to the output. So by selecting these, one of these will be selected and then it is connected to the output. So in the last class, if you remember, I have given the example of, what was the example that was given? Suppose you have a computer system which is connected to digital camera, video cameras, printers, and then screen recorders. Many devices are there, but you can only access one device at a given time. So which device you want to do will be selected by this, and the information from that will be sent to the output. So suppose you are charging your mobile phone and also transferring the photos or the pictures from the cell phone to your system. Both are not possible, only one at a time is possible. So which one are you selecting depends on this. So this is the example. So let me show you here, then we will see the control. So now what is it that we are talking about? This is your select, and this is, what is this? This is a 2 to 1. What is this 2 to 1? That means if this is not selected, this is not changing, see? 0, 0, 0, 1. It's not changing. So make this as 1, select this. So if you take 0, 0, it will come the output as 0. If you take it as 0, 1, still this is 1. See now, what it means is, if this is selected, if this is 0, it will be 0. The T1 line is selected because you are taking this as this. If I make this as 1, it is not changing. Let us see this. 1, 0. 1, 0. That means this line is selected because you are taking, this is connected to 1. So if you give 0, 0 is coming. If you give 1, 1 is coming. Right? Now, that means since we have taken 1, the line 1 is selected. Now let me make this as 0. That means 0 is given at the input. You are getting 0 at the output. Suppose I give 1, you are getting 1. Now what is it that you have to see here? Let me make it as a big screen. The changes here are not affected here. That means this line is only not selected. I change this. It is not affected here because this was a 0 line. Let me make this as 1. Then 0 is transferred, 1 is transferred. So this is how you will be seeing that it is working as a multiplexer, many to 1. Then yeah, it's coming. Go back to the screen. So this is how the multiplexer is working. Now this is a slightly different one. This is 16 to 1. It's loading. So you have 4 of them are connected. So let's not go into the details of this. 4:1 is better. Let's try this. First understand 2 to 1 you've done. Now let me see this. Four is to 1. This is easier to understand. First let us understand this, then we will go to the other one. So 4 inputs are there. These are the select lines. Okay. Suppose I make this as 0, 0. Then it will select which line? First line. If it is 0, it will be 0. If it is 1, 1 should come. It's taken. 0, 0 if you take, if you give 1, 1 will come. If you give 0, 0 is coming. Now these changes here, even if I change, this is not going to change. That is what you should observe. Only if there is a change here, it is changing. Now let me take 0, 1. Because it is, now next line is selected. If this is 0, this is 0. If this is 1, it is 1. Even if I change this to 0, it's not going to affect. Right? Next, 1, 0. When you take 1, 0, because this is 0, 0 is coming. If it is 1, one is coming. Similarly, if you take it as 1, 1, this is affected. 0 and 0. So therefore, this is how it is working. Now you can construct this also using I've seen already, I'll show you. You can construct these multiplexes using your circuit consisting of AND gates, what we discussed in the theory. I'll show you that. Multiplexer and demultiplexer, what we discussed in the class is this. Just look at the circuit. So what is this circuit telling you? You have to construct this circuit. In the simulation what I have shown was with the multiplexer as an integrated chip. So it is considered as an integrated chip and we have seen the simulation. Now here what we are doing is we have to construct using these AND and inverter gates. What is this circuit? 4 are there and S1 and S0. See, the notation can be different from different books. Some write it as S1 and S0 as select lines. In some books they are writing it as A and B as select lines. Whatever be the notation, these are the lines which are used to select one of these inputs to be sent to the output. So what are you require? You connect these lines with by means of these two inverters, and from the inverter what are you doing? You are connecting it to these set of AND gates, and sum of all these AND gates are all connected to the OR gate. So what actually it means is if you take S1 is equal to 0 and S0 also equal to 0. So first line, this is 0, this is 1. So this is 1, this is also going through this. So this is 1 here, this is also 1. Look at my cursor where I am holding. This is 1, this is 1. So it will select which line? I0 line it will select. If I0 is 0, now this is your OR gate. This OR gate has 4 inputs. The 4 inputs can come from any one of these AND gates, and your output is going to be 1 even if any one of the inputs is high. So whether this is high, this is high, this is high or this is high, your output is going to be definitely 1. So but from where the information is coming depends on your select lines. So suppose you take 0, 0, the information will come from Z is your output. The information will come from I0. If I0 is 0, you get it as 0. If I0 is 1, you will get it as 1. Similarly, 0 and 1. See, 0 and 1. S1 is 0. So that means this is 1. Right? But S0 is 1. So this is 0. So 1, this is your AND gate. If any of the inputs is 0, the output is going to be definitely 0 because it's an AND operation. So this is ruled out. Now coming to I1. I1, what is happening? This is your input. Now what are you taking? S0 is 1. So S0 is definitely 1. S1 was 0. So inversion will give you this as 1. So this, for this gate, for this second gate, both the inputs are high. So it will select I1 line. If I1 happens to be 0, then you will get it as 0. If I1 happens to be 1, you will get it as 1. Similarly, if you take 1, 0, 1, 0, that means S1 is 1, S0 is 1, S1 is 1, S1 is 1, but S0 is 0. So now what's happening? 1 and 0. 1 and 0 means this is 1. Okay, but 1 is inverted, so this becomes 0. Hence this is ruled out. Next, 1 means this is inverted. So the second gate also is ruled out. Coming to the third one, 1 and 0. So that means this is 1. So directly 1 is going here. And this is 0. So 0 is directly going here. So 0 after inversion becomes 1. So therefore, this gate has output as 1 and hence it will select Z is equal to I2. The last possibility is both 1 and 1. 1 and 1 you can directly see this is 1, this is 1. So it will select I3 line. And if I3 happens to be 0, you will get Z as 0. And if I3 is 1, you will get it as 1. So this is how you will be discussing about these circuits. Let us see the circuit now. Yeah, now it's a full screen. You are able to see it as a full screen. Okay. So I have already seen. So this is how the circuit is. Now let me show you. I have already constructed this circuit. I will show you how it is coming. Yeah, so my circuits, first let me show you the circuit. Can you see the circuit? Now the circuit is seen. See, I have connected 4 AND gates and continuously, this is, I will show you in the launch of the circuit. These are continuously and constantly given as high input. All the AND gates are given high inputs. Okay. Then, these two are my select lines. I have represented them as A and B. This is your S0 and S1. Maybe you can also write it as S0 and S1. Next, they are connected by means of an inverter. So then 1, 1 is taken, this becomes 0 and 0, right? So 0 and 0, this line is selected and you will get the information from this. 0, 1, this line is selected, 1, 0, this line is selected and so on. So now let me show you the actual operation of the circuit. Let me go to my circuits. You have seen the circuit. So for viewing, you just view the circuit. If you want to see its action, you have to go to the launch the simulator, and then see this. Now this is a new layout. They are constantly making some research. You are able to see this on either side. Just have a look. This is a better one. So this is a project. These are the circuit elements. If you don't want them to be seen, you can remove them. You can remove them, so that you can see the screen completely, or let them be on either side. Okay. So now are you able to see it, the complete circuit? Okay. So now what is this? You have inputs. I have taken the inputs from here. Remove all these things from the screen. These are my inputs. These are the inverters. These are your, where do you get them? Input. See, this is what I have taken here as inputs. These are, as you just hold it, you will understand. Can you see that this is power? All bits are always high. And this is just an input. It is a toggle input. Toggle input means what? It will be on or off depending on how many times you are pressing. And these are your AND gates. So I have taken this for this. For this I have taken this. Then what else I have taken? I have taken gates. Which gates have I taken? You hold this here. It will tell you that it is a NOT gate. Okay? NOT gate. These are the two NOT gates. Then one more thing I wanted to tell you. Here, till now you know how to use 2 input AND gates. Now you are using, what are you using? 3 input AND gate is what you need. Okay. So I am just holding it here and go to properties. One interesting thing is now, till now this is, they have changed it, they changed the layout. So now, till now since we used only 2, there was no need for us to add more. Now for this particular circuit you require 3 inputs. So you have here a bandwidth. I'll come to that bandwidth later. Input size. How many inputs you require? You require 3 inputs. Just say plus. Can you see that it's having 3 inputs now? Yes? So if you say 4, one more is added here. So like this you can add any number of inputs here and draw the lines like this. 1, 2, 3, like this. You have to draw the lines and then okay. So I think now, and then text box. Where will you have the text box? If you don't find, just go to search, say text will come. So you can write here, bring it here wherever you want and write it as maybe S1. You can increase the size to be able to see it. You are able to see it as S1, right? So this is my S1. So if you want S0, you write whatever you want, you can write. Fine. Now let us see how it is coming. Shall I increase it? Or you are able to see? Okay. So 0, 0. Okay. 0 and 0. Both are 0. When both are 0, that means which line is selected? The first line is selected. You give a proper label for all these things. I0, I1, I2 and I3. First one is I0 input. This is I1, this is I2 and this is I3. Output is definitely 1. But where from the information coming? The information is coming from this. Then 0, 1. See, you can see the information is now coming from this. So output is again 1. Then 0, 1, 0. When you do 1, 0, what's happening? This is 1, this is 0. So 0, this is 2. Output is high, but output is coming from this input. Let us keep both 1, 1. When you keep both as 1, 1, what's happening? This line is selected and this is going to the OR gate and your output is going to be 1. Fine? And you can just insert tools, combinational analysis. Okay. Now what should be your inputs? Inputs should be, you write whatever inputs you want here. I0, comma, I1, comma, I2, comma, I3. I'm sorry, I3. Yes? Anything? Any issue? Okay. So these are the inputs, and in the output you will write it as Q. One of you please mute yourself, or some noise I am getting from the background. Kindly mute yourself. Okay. Q, let me write it as a capital Q. So this is Q for me. Caps lock is on now. Fine. Next. Okay. You are able to see the inputs I0, I1, I2, I3. So if I0 is 1, okay, I should also take A and B into account, isn't it? So let me take let me say fit to screen so that you will be able to see this as well as that. Go to tools, go to combination analysis. My inputs should be A and B also. A, comma, B, comma, I0, comma, I1, comma, I2, comma, I3, right? So your output, what are you getting the output as? If you want, in some cases, if you need a decimal column, that also you can. Yes. Now 0, 0. So I0 is 1. You can enter this value here. Okay. So it is taking all possibilities as zeros. Okay. Okay, so 0, 0, I0 is 0. 0, 0, I0 is 0. Then, okay, so what is it that you want? You want output to be always 1 in all the cases. So you can write output as 1. Okay, so I0 is 1, it is not taking. So I0, maybe here it is taking. Where I0 is 1, when it is 0, 0, I0 is 1. So that means I0 is 1, this is 0, this is 0. Okay. So what it is actually doing is it is auto generating because you have given this as I and B. So maybe what you can do is you can select these lines 0, 0, 0, 1. Let me take only input as this. Input is A, comma B, So it will take 4 possibilities. In the output, let me write it as, what is it that you can take it as input, output is I0, comma, I1, comma, I2, comma, I3, comma, Q. So now 0, 0. So I0 is 1. I0 is 1. These are all zeros. Now you are able to see because you have a input is in your output. So 0, 1. 0, 1 means what? This is 0. This is 1. Okay. Let us not write output. Let us see the output and write. Then 1, 0, 1, 0, I2 is 1. This is 0, this is 0, this is 0, this is 0. Okay. Then 1, 1, 1, 1, this is 0, this is 0, this is also 0, this is 1, this is 0. So now let us give 0, 0. When you give 0, 0, let us see what happens. Are you able to see the circuit? Yeah. 0, 0. You can pull this so that it won't block your view. So 0 and 0. 0 and 0, what's happening? I0 is 0 and your output is 1. Next, 0, 1. 0, 1, what's happening? Your I1 is 1, output is again 1. Next, 1 and this is 0. This is 1. 1, 0. So what's happening? Your I2 is 1, Q is again 1. Q is again 1. Right? Then 1, 1. If you take it as 1 and 1, so it's coming from I3 again. It is 1. So you adjust this in such a way that you will be able to see your screen as well as your circuit. This is your circuit and this is your this thing. So you can have, what you can have? You can have, go to, what should you go to? Project, save online or save offline. So save online I have already done. If you want offline, say offline, it will be saved offline. So this is how you will be constructing these circuits. Okay. So let me go back to the other circuit. So this is about these multiplexes. So similarly, let me go to, I think I have already shown you all these things, and these are my groups. Let me see how many of you have shared. If you all join this, maybe you will be able to see. This is a new group. So earlier group I invited you people. This is a new version. If you are all interested, I will create a group here and you can all join and share your circuits. Okay. So this is so far a multiplexer. Now let me show you what is a demultiplexer. A demultiplexer, what does it do? A demultiplexer will do the reverse of what multiplexer is doing. So that means demultiplexer. So it is, that was many to one. Now this will be 1 to many. This is 1 to many. So that means it will have only one input, and that one input is available on many number of inputs. Okay, so it is like what could be the example? I think I have given you the example of dish antenna and cable TV in the last few classes. So or a dish TV person, he will have so many of us as subscribers, Each one of us will be paying either quarterly, monthly or whatever be the subscription. He will be receiving the channels from the satellite, and those channels what he receives, he will be sending it to all of us to our homes, direct to homes. So one is the dish and he is sending it to all of us. So how does he know, or how do you know that you are getting whatever quota you have to get, whatever channels you have? He will ask you to fill up some form or some such thing and ask you to give your wish list, the channels what you are interested in, and the bouquet they say, the Sony bouquet, ZN, whatever it is, and you have to tick and give it, so that you will be given a unique address, a unique identity. You will insert that card into the set-top box and your ID will be validated by the cable operator, and whatever channels you select only will be given. So that is 1, 2. So this is just an example I have given, and this is your already this is theory convert, this is already discussed. D, and this is enable. Enable, if it is 0, X is given here for the select. So whatever be the select line, if enable is 0, Y0 and Y1 is not going to change at all. So that remains the same. If enable is 1, if S is 0, the information is coming on to Y0, and if this information S is 1, it will come as 1. So 1, 1, this is what you are getting. So let us see, simple first. So the select line is given. So if it is 0, you will get it as 0. If it is 1, you are getting it as 1. If it is 0, it is going to 0. Suppose the select line is 1, then it will come on to this output. Let us see, 0 is 0, 1 is 0. As you can notice, the change is not happening on the first output line. The change is happening only on the second output line. Similarly, this is now 1 to 4. 1 to 4. The previous one was 1 to 2. Now this is 1 to 4. So what is 1 to 4? You have 1 and select lines are 2. So depending on the number of select lines you are using, you can generate 2 to the power n output. In this case, n is equal to 2. That means you can generate 4 outputs. So that means 4 outputs can be, it can be parallel port printer. This can be your, let us say, smart TV. This is printer. This is smart TV. Let us call this as some video capturing device. Okay. And this can be, maybe you can have 2 laptops connected. Now, if it is a Gmeet like this, you are able to send the information parallelly to all the devices all at the same time. But that may not be the case in all the cases. So you can send, say suppose you are in a network in the lab, and let there be some 40 systems, and since the person who is working on number 2 system wants to share something with number 39. So what you can do is, this is number 2, roll number 2, wants to share with, let us say, 10, 20, 30, 40. You can select their unique ID, their MAC address and their IP address, and send the information only to them. This is roll number 10. Then disable that, send it to 20, 30, 40. Thereby you are sending the information confidentially to only these devices or to these hall ticket numbers. Suppose you have an information which can be shared simultaneously to all the people. It is not confidential, but some notice that you want to generate. You can generate this notice by simultaneously selecting all these. So now what happens? Let us see. 0, 0, it will select this line. So if it is 1, 1 is happening. Next, 0, 1. 0, 1, 1, so it is 1. If it is 0, it is 0. This is not changing, see. Whether I give 1 or 0, it is only the first line that is selected and the information is changing only here. Similarly, let me make, this is not changing. Similarly, 1, 0. When I take 1, 0, see where is it changing? It is changing here. These two are not affected. If I give 0, we are getting 0. If I give 1, we are getting it as 1. Right? Next, 1, 1. 1, 1 when you take, it's going to 0, 0. That's why this is changed. Go to 1 and 1. Because it is 1, it is 1. If it is 0, you get it as 0. These three are not changing. So this is how 4 to 1 circuit will be working. A little complicated is 16 to 1. So you can connect all 16 to 1 using all these AND gates, or you have here, say 3 is generating. This is 3 is to 8. We have seen 2 to 4. Now let us see 3 to 8. So 0 0, if it is 1, it is changing. 0 0 1, it is changing here. 1 0, it is changing here. Right? Let this be as 1 always. So 1 0, 1 0, it is changing here. 4. How do you read this as 1 0 1? 1 0 1 is 5. Can you see 5? Similarly, 1 1 0. 1 1 0 is 6, it is changing here. All ones is 1, it is changing here. So this is how you will be working, and this is using an integrated multiplexer chip that it is shown here. You have to construct them using, what should you use? You must use your AND gates and inverter OR gate, and however I have shown you, it should be constructed like that. Let me show you. Demultiplexer. Demultiplexer, this is what is being shared to you in your manual. So you have now data input is always 1. You can see data input, see where my cursor is, data input. This data input is always high. It is always connected to all the inputs. If you give high here, you will get high on these output lines. Now which output line it is coming is decided by your S0 and S1. What are S0 and S1? They are your select lines, S0 and S1. Now they are connected by means of an inverter, as you can see, isn't it? You can see that I am opening the Google Docs, maybe that is better. So therefore, if you take S0 and S1 as 0 zeros, you will have the information available on D0. 0 1 D1, 1 0 D2, and so on. Now let us see what is happening. One second. So 0 0. This inversion is given before, or you can give it here also. Then what's happening? This is directly going from here. First line is D0. Where is it coming from? This is input. This line is coming here. This line is going . This. Let me go back to that screen. This is the manual that was provided to you. You can just look up that for the circuits. This is multiplexer. This is a demultiplexer. Slowly I go. Yeah. Okay. So now this is 0 and there is an inversion. Or you can convert it as an inverter and give 0, 0 as before. This is 1, you will get this as 1. And data, these two are both high. Data is whatever data you are giving. If you give 0, it is available on D0 line. And if you select this as 0, 1, the information is available on D1. 1, 0, it will be selected on D2. 1, 1, it will be selected on D3. So, these are the select lines. 0, 0, if you give 0, you get the information on the first output line as 0. If you give 1, you will get it as 1. But the line is selected only 0 line. Next, 0, 1 means first line is selected. If you give 0, 0 will come here. If you give 1, 1 will come here. You are able to see both the possibilities. 1, 0, the second line is second output 0, 1, 2, 3. The second output is selected. So if you give 0, you get it as 0. If you give 1, you will get it as 1. Next, 1, 1. If you take 1, 1, the third output, that is 0, O3. It's not 0, 3, it's O3. Output 0, output 1, output 2 and output 3. So last if you gave 1, 1, okay. If you give 1, 1, what's happening? If you give 0 at the input, you get the output as 0. If you give the last row, if your input is 1, you will get the output as 1. So this is how you will be doing it. Okay. Now let me show you how to construct this circuit. So this is how the circuit is coming. So what all you need? First, let me show you how to take now input. What inputs you will take? You need the two select lines, right? 0 and give a label for this. What label you will give here? Maybe you call this as let us say S1. So S1 is my this. If you want to increase the bar, you can do that. Fine. Next, bring one more. So what label will give this as? S0. S0. If you want, you can give S also as a capital. S0. Similarly here also, you can give this as capital. So this is how you will be doing this. Next, this is over. Now, so these arrows you have to manipulate. Then what else you need? Gates. What gates you need? Inverter. Bring that here. Bring the second inverter here. If it is like this, it is not convenient for you to do this. So what should you do? Click on this. Can you see direction here? This direction, you put it as, you can keep it as right, left, it will go left. If you say right, it will go right. If you say up, it will go up. If you say down, it will go down. Generally, convention is to have it like this so that you can make the connection. Similarly, you have to select the device first, select the input, and you want it to be down. So, you are able to see this as down. Now, you can hold it and bring it to the left or right. Click and drag, same concept. So, draw lines from here, draw lines from here, and connect this. So if you feel this is not convenient, select this and say delete, it will be deleted. This also delete. Maybe I can push it little to the right. So it's connected. Now this is getting connected. However, you draw the circuit like this, you can connect. So select this if you are not happy. You can say Control Z, or here also you have, you see, undo. You can undo that and join here like this. Okay, so now what else you need? If you want, you can just put it this way. The circuit diagram should be neatly drawn. So until that time, if you are not happy, please practice it. I have given you the link. You can go anytime to this. It is available on the browser, and please practice. Next, what else you need? You need, if you don't want this window to be on, you can suppress it. But right now you need it, so I am just keeping it. Okay. Now, the moment you click and drag it here, it will ask you the input size. What should be the input size? See, as it is by default, it is 2. If you want to make it high, 3. If you say 4, 4. You need only 3. Now you need not drag every time. There is an option here to copy and paste it. So Control V. You can select Control C, Control V, Control C, Control V, and Control V. Control Z is not working here, so maybe undo. So Control C. Sometimes it works. These are all senses. This is Control V. So like this, you can connect whatever you want. So if you want 1, connect it here. 1 when will you need? You need 1 here for the last one. Similarly, here. Okay, so this is 1. Then what else you need? Input. This is this input. I told you continuously high. So you can connect it wherever you want. So if this is 1, this is 1, this is 1. Okay, connect an output here. And OR gate, all those things you can connect. So if you want if you want to suppress it, press this arrow back. Go to, what is it now? Gates. Gates, which gate you need now? OR gate. So you need 4 input, because this is 1 to 4 is what you are using. So bring that here. See, just come here. Leave it here. Input size 3. You can see 3 dots coming. Isn't it? Say 4. You will see 4 dots coming. So this is how you will be constructing. I think I will. I need some time. I won't be completing. I won't be able to complete even if I start. So let me just